What's going on, everyone? It is Jaron from Jeranism back with another live video for you today. Thank you so much for joining me. I do appreciate it as always. Just saw that I'm at something like 144,940 something subscribers, which is simply amazing. I can still recall my very first video, which was more than 4 years ago now, and I can remember my very first sub and calling my wife when my video had 100 views. So definitely have come a long way, and I owe it all to you guys. So appreciate it so much. Thanks a million, especially to my patrons for helping me keep this channel going. Truly a very blessed person, and I just wanted to say thank you guys very much from the bottom of my heart. Okay, and on to that topic of today, which if you watched Globebusters yesterday, you've already heard Bob read this article, but I wanted to read it again, add some of my own comments and some emphasis, and so that's the plan. And then I'll be getting ready for Jeranism Monday Night Raw, which remains the #1 show on Truth Frequency Radio from 6 to 8 p.m. Pacific and 9 to 11 Eastern on Monday nights. So I hope you guys join me over there later, and that's at tfrlive.com. So before we get to this article, let's start with some quotes to kind of set the stage. Of course, this video is titled Scientific American Cosmology Has Some Big Problems. And no one actually highlights that better than Michio Kaku. So let's start by hearing him out, and let's hear what he's got to say about the current problems in cosmology.
Usually in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. We're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120. That is 1 with 120 zeros after it. This is the largest mismatch between theory and experiment in the history of science.
So he's talking there about the largest mismatch in the history of science, talking about the difference between the tests and the theories, of course. I also wanted to point out real quick just another quote to kind of get the stage set. And I've also probably said this quote hundreds of times in my videos because it's very important to me personally. This is the one that kind of turned the page for me as a former science believer, thinking that everything science said must be true. It's what I was taught in school. Everything goes through the scientific method until I saw this quote by a very famous cosmologist, George Ellis, who in the Scientific American Thinking Globally, Acting Universally article from October 1995 stated this. He said, "People need to be aware that there is a range of models that could explain the observations. For instance, I can construct you a spherically symmetrical universe with the Earth at its center, and you cannot disprove it based on observations. You can only exclude it on philosophical grounds. In my view, there is absolutely nothing wrong with that. What I want to bring into the open is the fact that we are using philosophical criteria in choosing our models. A lot of cosmology tries to hide that." So really, when you break down that quote and you realize what he's saying, and you understand that cosmology is a science, and I believed in science, and I think science tells the truth, and would never hide anything, but this right here is from a famous cosmologist, a physicist, who tells us flat out that they're using philosophical criteria in choosing their models, and a lot of cosmology tries to hide that. So that should be an eye-opener for anyone. Why is cosmology, a science, trying to hide something from me? Doesn't really seem to make a lot of sense. Sorry if my sound was a little bit loud there. I forgot to turn it back down after that little quote from Michio Kaku. But I fixed that now. So anyway, when you hear all that and then you let me read this next article, and you should have your eyes opened as to what we are dealing with here. And so let's move on to that article. Let me get it set up for you. And that article is from the Scientific American, like I said. Let me get you so you can see what I'm looking at. And here we go. All right, so this article was from April 30th, 2019. It says cosmology has some big problems. It says the field relies on a conceptual framework that has trouble accounting for new observations. It is written by Bjørn Ekeberg, and again, that was April 30th. And if we scroll down to the bottom of this article real quickly, you can see that Bjørn Ekeberg is a PhD, philosopher of science, and author of Metaphysical Experiments, published by the University of Minnesota Press. All right. So let's read this article, and hopefully people can start to see what I'm seeing and what a lot of us have been trying to say for many years now. There is a problem in cosmology. Even if you take back what Michio Kaku said, they're off by a factor of 10 to the 120th, which is a 10 with 120 zeros after it, which is simply ridiculous to be off by that kind of a factor. But let's go ahead and read this article and see what it's got to say. Okay, here we go. So it says, what do we really know about our universe? Born out of a cosmic explosion 13.8 billion years ago, the universe rapidly inflated and then cooled. It is still expanding at an increasing rate and mostly made up of unknown dark matter and dark energy, right? This well-known story is usually taken as a self-evident fact, despite the relative lack of empirical evidence and despite a steady crop of discrepancies arriving with observations of the distant universe. In the recent months, new measurements of the Hubble constant, the rate of universal expansion, suggested major differences between two independent methods of calculation. Discrepancies on the expansion rate have huge implications not simply for calculation, but for the validity of cosmology's current standard model at extreme scales of the cosmos. Another recent probe found galaxies inconsistent with the theory of dark matter, which posits this hypothetical substance to be everywhere, but according to the latest measurements, it is not, suggesting that the theory needs to be re-examined. It's perhaps worth stopping to ask why astrophysicists hypothesize dark matter to be everywhere in the universe. The answer lies in a peculiar feature of cosmological physics that is not often remarked. For a crucial function of theories such as dark matter, dark energy, and inflation, which each in its own way is tied to the Big Bang paradigm, is not to describe known empirical phenomenon, but rather to maintain the mathematical coherence of a framework itself while accounting for discrepant observations. Fundamentally, they are names for something that must exist insofar as the framework is assumed to be universally valid. A lot of things we're going to see like that in this article. Assumptions have to be, if your foundations are wrong, what happens after that? Let's continue. Each new discrepancy between observation and theory can, of course, in and of itself be considered an exciting promise of more research, a progressive refinement towards the truth. But when it adds up, it could also suggest a more confounding problem that is not resolved by tweaking parameters or adding new variables. Consider the context of the problem and its history. As a mathematically driven science, cosmological physics is usually thought to be extremely precise. But the cosmos is unlike any scientific subject matter on Earth. A theory of the entire universe, based on our own tiny neighborhood as the only known sample of it, requires a lot of simplifying assumptions. When these assumptions are multiplied and stretched across vast distances, the potential for error increases, and this is further compounded by our very limited means of testing. Okay? Historically, Newton's physical laws made up a theoretical framework that worked for our own solar system with remarkable precision. Both Uranus and Neptune, for example, were discovered through predictions based on Newton's model. But as the scales grew larger, its validity proved limited. Einstein's general relativity framework provided an extended and more precise reach beyond the furthest reaches of our own galaxy. But just how far could it go? The Big Bang paradigm that emerged in the mid-20th century effectively stretches the model's validity to a kind of infinity, defined either as the boundary of the radius of the universe, calculated at 46 billion light-years, or in terms of the beginning of time. This giant stretch is based on a few concrete discoveries, such as Edwin Hubble's observation that the universe appears to be expanding. Again, I'm just going to point out here how funny that line is. This giant stretch is based on a few concrete discoveries, such as Edwin Hubble's observation that the universe appears to be expanding. That was in 1929, and the detection of the microwave background radiation in 1964. But considering the scale involved, these limited observations have had an outsized influence on cosmological theory. It is, of course, entirely plausible that the validity of general relativity breaks down much closer to our own home than at the edge of a hypothetical end of the universe. And if that were the case, today's multi-layered theoretical edifice of the Big Bang paradigm would turn out to be a confusing mix of fictional beasts invented to uphold a model, along with empirically valid variables, mutually reliant on each other to the point of making it impossible to sort science from fiction, which is exactly what we've been saying for 4 years. Compounding this problem, most observations of the universe occur experimentally and indirectly. Today's space telescopes provide no direct view of anything. Again, today's space telescopes provide no direct view of anything. They produce measurements through an interplay of theoretical predictions and pliable parameters in which their model is involved every step of the way. Again, this is what has been being said for years. The framework literally frames the problem. It determines where and how to observe. And so, despite the advanced technologies and methods involved, the profound limitations to the endeavor also increase the risk of being led astray by the kind of assumptions that cannot be calculated. After spending many years researching the foundations of cosmological physics from a philosophy of science perspective, I have not been surprised to hear that some scientists openly talk about a crisis in cosmology. And again, you can just go back and listen to what we just played with Michio Kaku. We can listen to the quote again by George Ellis telling us that there's a problem, that he's trying to bring out into the open the fact that we are using philosophical criteria in choosing our models. A lot of cosmology tries to hide that. And in a second, we'll look at another quote by Edwin Hubble, which I've also played many times, that can actually help concrete that. After spending many years, oops, I already read that part. Let's see here where we're at. Okay. In the big inflation debate in Scientific American a few years ago, a key piece of the Big Bang paradigm was criticized by one of the theory's original proponents for having become indefensible as a scientific theory. I also am not sure who he's talking about here, but I do think it's George Ellis. George Ellis was one of the major original proponents, but he has now gotten to the point where he says this is indefensible as a scientific theory. It has gone away from science. Why? Because inflation theory relies on ad hoc contrivances to accommodate almost any data, and because its proposed physical field is not based on anything with empirical justification. This is probably because of a crucial function of inflation is to bridge the transition from an unknowable Big Bang to a physics that we can recognize today. So, is it science or is it a convenient invention? A few astrophysicists, such as Michael J. Disney, have criticized the Big Bang paradigm for its lack of demonstrated certainties. In his analysis, the theoretical framework has far fewer certain observations than free parameters to tweak them, a so-called negative significance that would be an alarming sign for any science. As Disney writes in American Scientist, a skeptic is entitled to feel that a negative significance after so much time, effort, and trimming is nothing more than one would expect of a folk tale constantly re-edited to fit inconvenient new observations, which is exactly what we get from today's astrophysicists, today's cosmologists. As I discuss in my new book, Metaphysical Experiments, there is a deeper history behind the current problems. The Big Bang hypothesis itself originally emerged as an indirect consequence of general relativity undergoing remodeling. Einstein has made a fundamental assumption about the universe, that it was static in both space and time, and to make his equations add up, he added a cosmological constant, for which he freely admitted there is no physical justification. So if people want to call that science, good for you. Go on believing people's theories that they call them science, call them fact, call them proven, call them whatever you want. They're none of those. But when Hubble observed that the universe was expanding and Einstein's solution no longer seemed to make sense, some mathematical physicists tried to change a fundamental assumption of that model, that the universe was the same in all spatial directions but variant in time. Not insignificantly, this theory came with a very promising upside, a possible merger between cosmology and nuclear physics. Could the brave new model of the atom also explain our universe? From the outset, this theory only spoke to the immediate aftermath of an explicitly hypothetical event, whose principal function was as a limit condition, the point at which the theory breaks down. Big Bang theory says nothing about the Big Bang. It is rather a possible hypothetical premise for resolving general relativity. Hopefully people start to see what's going on here. When you've got lie on top of lie, off a mistake, off of a faulty foundation, what do you think you end up with? Garbage in, garbage out. There's no way you're going to reach a truth when your foundation is so terribly messed up. I mean, think about what we've gone from. We've gone from plausible to absurd in a matter of no time, in a matter of 100 years, if you want to call it that. They've gone from something that says, interesting, maybe I'll think about that, to, what are you kidding me? And yet people have followed along like sheep and just, tell us more. On top of this undemonstrable but very productive hypothesis, floor upon floor has been added intact with vastly extended scales and new discrepancies. To explain observations of galaxies inconsistent with general relativity, the existence of dark matter was posited as an unknown and invisible form of matter calculated to make up more than a quarter of all mass energy content in the universe, assuming, of course, the framework is universally valid. In 1998, when a set of supernova measurements of an accelerating galaxy seemed at odds with the framework, the new theory emerged of a mysterious force called dark energy, calculated to fill circa 70% of the mass energy of the universe. The crux of today's cosmological paradigm is that in order to maintain a mathematically unified theory valid for the entire universe, we must accept that 95% of our cosmos is furnished by completely unknown elements and forces for which we have no empirical evidence whatsoever. Let me just read that line again, because if you can't grasp that, if you want to continue believing these guys out there, Simon Dan and all these guys who are so heavily invested in this theory, which has no empirical evidence at all. Again, the crux of today's cosmological paradigm is that in order to maintain a mathematically unified theory valid for the entire universe, we must accept that 95% of our cosmos is furnished by completely unknown elements and forces for which we have no empirical evidence whatsoever. So where he says we must, well, I change that. I say we don't must. I don't have to. I don't have to accept it, and I don't accept it. And that's the only difference between you, me, and many others, is whether or not you simply bow down to the people above you, these people that are this scientific dictatorship, if you will, that tells you what you must and mustn't believe. Okay? So they tell you, you must accept that 95% of our known universe is furnished by something completely unknown. Does that sound like science to you? No. Where's the evidence? Where's the proof? Where's the experiments? There is none. Let's continue. For a scientist to be confident of this picture requires an exceptional faith in the power of mathematical unification. So there's a lot of people out there that have been told that math is reality, and as long as you have an exceptional faith, and when you see this, doesn't it ring true when I've made video after video after video calling science a religion? Do you see now why? If it requires an exceptional faith in something man-made, remember the mathematical unification, the mathematical formulas is all man-made. So if you require a faith in a man-made idea, that's a religion. That's exactly what it is. So anyone who says science isn't a religion, well, what are they talking about? If it requires a faith that 95% of the known cosmological universe cannot be detected, has never been seen, has never been proven, but you must believe in it, that's exactly the definition of religion. It's word for word. In the end, the conundrum for cosmology is its reliance on a framework as a necessary presupposition for conducting research. For lack of a clear alternative, as astrophysicist Disney also notes, it is in sense stuck with the paradigm. Do you see the problem here? They're already stuck in that line of thinking. There is no way out. And I've described it before as a person walking on a high wire. You know, they're walking across. Anybody who walks across a high wire, the number one rule is don't look down. You have to just look across, walk yourself across from building to building or from pole to pole, whatever you're doing your high wire walking across, but don't dare look down. The second you look down, that's when you start to get dizzy. That's where you start to lose your balance and where you might fall. Cosmology is exactly the same. They have to make sure that they don't look at the framework, that they don't look at the foundations for which everything that they believe is built on. That's why Neil deGrasse never thinks about what the curvature formula is for the Earth curvature. He would never look at that. That requires him looking down at the ground that he's walking on. He's not going to do that. He just has to keep plugging forward. We've already proven the Earth's a sphere. We've already proven that these things are facts, and he keeps moving forward, never looking at the framework which it all relies on. In the end, I read that. It seems more pragmatic to add new theoretical floors than to rethink the fundamentals, right? So this is the problem that I'm talking about. They're adding these floors to this building, but they're not checking the foundation. So they keep adding floor after floor after floor after floor, and what do you think is eventually going to happen? Well, whether you realize it or not, that building's going to fall. When it's going to fall, I don't know. You know, will it be in my lifetime? Will it be in your lifetime? Depends how many people wake up to the fact that we keep adding floors to a faulty foundation. Contrary to the scientific ideal of getting progressively closer to the truth, it looks rather like cosmology, to borrow a term from technology studies, has become path-dependent, overdetermined by the implications of its past inventions. So, hopefully people can see what's going on here. I'm not sure if they can. I'm not sure, if they need to read this article for themselves. By the way, again, this is written by Bjørn Ekeberg, PhD, and there will be a link, or is a link, in the description of this video if you want to read it yourself. Make sure it didn't come from The Onion, because it sounds like it did. Sounds like it doesn't belong in Scientific American, but this is just somebody simply pointing out the problems of cosmology and not just simply accepting it and moving forward with their life and making money off these theories and continuing to do whatever they want within that faulty foundations. The foundations are faulty. They have more holes than Swiss cheese, and yet people want to believe. They want to believe that these men of great intellect know all the answers, and that they will tell them all the answers if they just sit in a desk and read a book And if you memorize this faulty foundations, think that's what these guys get their degrees for, is memorizing the parameters of the faulty foundations. Is this the way science is supposed to be? Phew, not in my book. By the way, if you want to hear this Edwin Hubble quote, or if you want to find a good page to find it, simply type in Jeranism Hubble in the Google search, and you will find this article. I believe it's the #1 thing that comes up on on Google search. If you just type in Jeranism Hubble, you'll get my website and this article, Edwin Hubble and the Lie That Keeps on Lying. Basically, we're just going to be quoting Edwin Hubble here. I won't read the full quote, the long quote, but you can go to that link if you want. It's also in the description. So come on over and read this article. But basically, I just want to read this one particular quote by Edwin Hubble so that you start to understand the problem here. Remember earlier in this article, if we kind of fire back up here, when he's talking about Hubble, and he's talking about the expanding universe. So here we go. When he's talking about this giant stretch is based on a few concrete discoveries, such as Edwin Hubble's observation that the universe appears to be expanding. Well, the problem with that observation is it placed the Earth at the center. And so they quickly had to change that. And you might think, well, Jaron, you're just saying that. There's no way that they actually feel that way. No, let's read this quote here by Edwin Hubble. So he's talking about such a condition, and we're talking about the fact that we appear to see things expanding, moving away from the Earth in every direction. Such a condition would imply that we occupy a unique position in the universe, analogous in a sense to the ancient conception of a central Earth. This hypothesis cannot be disproved. So, have you ever heard that the Earth might be the center of the universe? Of course not. Of course that's not proclaimed, because science has moved past that. They don't want that to be the case, so this is men's choices. And again, when you hear over here, when I talked about George Ellis's quote, when he said, we're excluding it on philosophical grounds. This is what is being excluded on philosophical grounds. The fact that the Earth cannot be the center of the universe. It cannot be created. It cannot be important. We cannot be central. And so you have George Ellis saying we can only exclude it on philosophical grounds, which is not a reason to exclude anything if you're talking about science. And then he says, what I want to bring into the open is the fact that we are using that criteria in choosing our models. So they've chosen this model based on the fact that they simply don't like the other one. How do we know? Let's continue. This hypothesis cannot be disproved, but it is unwelcome and would only be accepted as a last resort in order to save the phenomenon. Therefore, we disregard this possibility. Well, that's really scientific. I'm standing in awe of the brilliant minds who have disregarded a possibility based on observations. They're saying, hey, observationally, it cannot be disproved. However, it is unwelcome, and we disregard this possibility. The unwelcomed position of a favored location, meaning that the Earth could be central, must be avoided at all costs. This is the only line you need to read here, folks. These are men of science who are saying, based on observations, it could be this, could be that, but this one idea must be avoided at all costs. Why? Why? Such a favored position is intolerable. It's intolerable? Why? Just because you want to be the most impressive thing that ever existed on the Earth? You don't want to open it up to the idea that there's something far more superior than you? That there's a thought process behind all this? Look around, folks. Evidence of creation is all around you. Evidence of intelligence is all around you. Yet they disregard this possibility. The unwelcome position of a favored location must be avoided at all costs. Such a favored position is intolerable. Therefore, in order to restore homogeneity and to escape the horror of a unique position. Can you imagine these are men of science? Well, we got to escape the horror of a unique position. What is a horror about that? Must be compensated by spatial curvature. There seems to be no other escape. Okay? So again, and I go on and talk a little bit about this, and also I have the larger quote up here where he's talking about all the things that, both explanations seem plausible, but neither is permitted by the observations. Oh man, just too funny. So again, I just wanted to point that out. Cosmology has some major problems. That is the absolute truth. And when will people wake up to that?